Okay, so today it's gonna be an interesting one. I'm going to use the Evo guide with the SV220 filter, but I'm not gonna use the 405cc today. I'm gonna test out the SV705C with the Narrowband to see what it can do in the summer conditions. As you know from my videos, I like to experiment with my stuff. I'm not that kind of guy that uses the best stuff that is available. I like to experiment. I also bought a new telescope. It's coming soon, like next week I think, which I will do a review about, and some first light testing, and we're gonna see what an uncooled sensor is gonna do in the summertime. So a lot of people ask me, like, is cooling necessary? Yes and no. Yes, it's beneficial, but it's not 100% needed. You can image without it, but it's definitely beneficial, especially if it gets really hot. But which is part of why I'm gonna do this video, so that I give you an idea what you can do with an uncooled sensor. So here we go. It's dark already, and I have the setup outside. It is imaging at the moment, but I just want to show you what I'm using. It's the lovely Evo guide, as you have seen in many of my videos. It's a guide scope mainly, but it can be used for imaging. This is the SV165 guiding scope. This is the ZW ASI178MC and the SVBONY SV705C. It's a IMX585 sensor. This is the camera is like the ASI 585 but much cheaper. And this is the adventurer mount. It's all balanced and ready to go. I have everything plugged in with my TP-Link router. This is about 45 euros. Not router, sorry, it's a USB hub, powered. It's about 45 euros. And I removed the pier at the moment being, because I have used it this week and it was a bit windy, and I removed the pier and I just left it as is. Today it's not windy, but I didn't want to mess around and put the pier again. And yeah, well, actually at the moment I'm waiting for some clouds to pass and then continue imaging, because there are a bit of thin clouds at the moment, so we'll see. So today I'm gonna image the Nebula at the Cygnus 32. It's in the Cygnus constellation. I'm starting polar alignment now. I never done this nebula, so it's gonna be pretty cool. I'm gonna polar align the Evo guide. Okay, turn to the other side. Oh, we are not so very close. No. Okay, now I'm gonna go to some stars, and then I will remove the camera and place a filter instead. After, sorry, 2-star alignment. Chop. Solder is a good one. I'm using the 585 sensor, by the way, today, not the 294 sensor, so I wanna test out some deep sky imaging with uncooled, because I always use cooled, but I never tested out. I mean, sometimes I test it out, but Yeah, this is Capstar. But I wanna test it out a bit today because I'm getting a new telescope soon. And the 585 sensor is the one I'll be using mostly with it. So I wanna see what it's able to do. Just so you know, with the 585 sensor, it's more sensitive than the 294. Because I used it before with Narrowband. It gets the same details as the 294, but much faster. Because it's a newer sensor, you know. It's much more sensitive. Alright, that's it. Now I'm gonna remove the camera and put the filter on. Alright, I installed the filter and I'm gonna focus with the button of mask on. I'm gonna increase the exposure a bit. It does look quite close to focus, but yeah, I went the wrong way. I think this is decent. I'm gonna move it a bit to the clockwise. Move it a bit more. And I lock the focus and I'm gonna see what we get. Should be in focus now. I'm gonna touch it very slightly again. This is the madness you run into when trying to find perfect focus, but it should be pretty good. So this is the first sub of the Soul Nebula. I changed my mind actually. I was imaging another nebula at Cygnus before, but it wasn't going really well. And it clouded up pretty good, so I said to myself I better test on a pretty bright nebula, so I see what it can do on that first and then move on to other harder targets. So that's what I did. As you can see, the Soul Nebula fits really well in this field of view with the 585 in the overguide. And this is my dithering. You can see it's going really well. And I have my FWHM filter, which will reject any stars that are bigger than 4.9. Basically means that trail stars won't be added. I'm also saving the subs. Save except when post dithering, so it will save the frames only. It won't save the dithering as well. And just an FYI, when a target is low, dither every 2 frames. When the target gets higher, it's okay to dither every 4 or 5 frames, but when it's low, till you get like 1 hour, 2 hours exposure, it's better to dither early than leave it. It's better to dither more when you are early in the life stack, basically. And guiding at the moment it's not very high. Actually it's pretty low, the Soul Nebula at the moment, but when it's low the guiding won't be that accurate, so this is pretty pleasing to see, given that the target is low. And hopefully I will leave the telescope out all night. Hopefully. And we'll see what a budget planetary camera can get. So this is day 2 of trying my planetary camera, SV705C on the Soul Nebula. As you can see, today it's much better. You can see really good signal to noise ratio, and also the calibration frames worked awesome. Yesterday I did a mistake. I only did like 2 darks because of laziness, but today I did 20 darks and 30 flats, and it worked out great. Yesterday I had streaks going on in the image, so it wasn't that great, but today it's going well, yes. And I have something clouds going on. I have to stop sometimes, like I have stopped for 20 minutes earlier and continued when it passed, and I have something close coming again now because I can see them, but it's going good. You can see the guiding is smooth. I have really good, decent guiding. Before it was even better than this, like it was 0.2, but the stars are round, so it's not an issue. And yeah, it's 2 hours so far. I think I'm gonna delete the data of yesterday because it wasn't that good. And the only disadvantage of this camera is, since it's uncooled, as you can see, there is a bit of noise. So this will go with more and more integration, but this is the downside of using a uncooled camera. So if you are wondering what are the differences, this is the weakest point of an uncooled camera, is the noise. An uncooled camera is much less noisier. So if you live in a high temperature country like where I live, get the cooled camera, not uncooled. But uncooled will work, but you just need a lot more integration to average out the noise, but it's pretty good. And I'm gonna let it stack. I have to, like, the more the better, obviously, but I don't know how I'm gonna get a lot because I have clouds coming, as I said, but we'll see. So this is how the Soul Nebula looks with almost 3 hours. It's really fantastic looking. Yeah, it has noise. Obviously we're using an uncooled sensor, but it looks really lovely. And we can get rid of this noise in Graxpert, so I'm not really that worried about it. But to get this close up from a 50mm telescope is impressive. I'm using 3-minute exposures and 252 gain. It is at unity gain, so the best gain of this sensor. I love it. So good. This is gonna turn out awesome, I can already tell. And guiding is going okay. 0.3 RMS error, 1.3 arc seconds. The size of the stars is 4. That's the word. And yeah, it's going really good. It's a bit noisy, but you know, it's an uncooled camera. But this is a test. This is so we can see what can be achieved with an uncooled camera. And I'm gonna take as much data as possible and show you the end result. So I'm at the end of the night. I'm 300 minutes exposure, and this is the end result, in the live stack at least. And this is how it started. Like you can see, there's a ton of noise, and I'm going to show you kind of the end result. There's an auto stretch. So this is the end result. As you can see, it's a pretty good result for an uncooled camera. So we'll see what comes out when we process this. But yeah, this is your answer if you need a cooled camera or not. To me, an uncooled camera does a pretty good job. So that's it basically.